Hello Standard 2 students. I'm going to go through the sample examination questions for the networks topic. So you might recognize this one because you had it in your previous paper. It wants the sum of the degrees of the vertices in this network. So remember that the degree of the vertex is the number of edges coming off it. So here, if I change that to there, I have one edge coming off there, 4, 2, 3, and 2. If I add that up, 5, 7, 10, 12, then D is my answer there. This question's repeated again, so I'll do it for the long answer version. Okay, a weighted network diagram is shown below. Now, what is the minimum spanning tree? So let's start with the two shortest edges, like that. We don't want to include 6 because that would make a loop, or 3. There's 3 over here. So we can use this 3 and that 4. We've got our spanning tree, and if we add that up, we get 4 plus 3 plus 2 plus 2, which is 11. And if you tried other combinations, you'd find out that that would be the minimum one. We've done this question already. I will recap it again. So we have here that we have a minimum total length of pipes needs to be provided to all locations. Any one location can be the source of the supply. So let's choose the shortest path here. So we'll try Parkview to Somerville. And now we need to connect to Beachview. So 10 is the shorter path compared to 15. We connect Newville, and then Old Town can be connected by 12, 14, or 11. So 11 is the shorter one. So 11 plus 10 plus 7, plus 8 plus 5 will give me 34. So that's the answer there. We have an organisation of a school formal includes activities A to L. The diagram shows the activities and their completion time in days. So we are told here that the minimum completion time is 24. So upon closer inspection, you can see that A, D, F, H, and L add up to 24. We want to know the float time for activity E. Now, if we go here, it'll be 21 days to here if L is 3 and finishes at 24. So I can go backwards from there and subtract activity J, which is 4. So my latest start time will be 17. Going forward from the start, I can go 3 plus 4 plus 4 is 11. So that's my earliest start time. So the difference between my earliest start time and my latest start time is my float time, which is 6. We've done this one previously. Let's recap. The network diagram represents a system of roads connecting a shopping centre to the on-ramp of a freeway. The traffic moves via several routes. For example, there are 2 routes from shopping centre P. So it tells you this one, and it also tells you 1 route from T to U. It gives you that, so it helps, tries to assist you with interpreting the diagram. The number on the edge of each road indicates the number of vehicles that can travel on it per hour. Now, if you have a look here, you can see that from the shopping centre, 70 plus 85 can leave per hour, which adds up to 155 vehicles. You can see on the on-ramp, 63 plus 92 also adds up to 155. So we want to maximise that flow. Now we can see here P, leaving P is 65 and 90 is 155, but we only get 135 getting onto R, as 65 enter Q, and only 45 leave. So that means we could maximize flow by making a route that would take 20 cars per hour there. Now, looking at S, S has 50 cars arriving and 30 leaving, so S can also absorb another route of 20 cars per hour. Now we realize that from T to U, only 115 cars are entering U per hour, which is a gap of 40. And we've got that 20 and 20. If we just join two roots onto U like this, we would maximize the traffic flow. So that corresponds to the answer for D. Now we've got this question here again. So what I did here is I showed that I've got X to Y to Z and then to W. So I'm joining that to that, to that, to that, and then that. Using the table values, I can see that X to Y is 500. Y to Z is 340. X to Z is 220. X to W is 650. And W to Z is 280. Make that clear, right? That's a Z there. So I want to, a petrol tanker needs to refill each station. It starts at W and visits each station. What is the shortest distance? So if I have a look at that and I go from W to Z to X to Y, so W, Z, X, Y, I will get 280 plus 220 plus 500 equals 1,000 meters. I can try the combinations. I can go WX, YZ, and go WX, ZY, and I'll find out that it's greater than 1,000. So you'll find out that that'll be the shortest route. Their diagram can be slightly different. It's still the same thing. You still have the same values for the distance between each petrol station. So they also get 1,000 as the answer there. Now we have another question here. A park has 5 areas, A, B, C, D, and E, which are connected by pathways. The table shows the length of some of the paths in meters. So if I substitute the values in there, A to B is 600, so I can put that here. I've got B to A 600, which is fine. B to D is 500. C to D is 400. And E to D is 300. So that's how you get your values from the table and put it on your diagram. Now let's have a look at the question. Complete the network diagram, including possible value for each of the two edges, AE and BC, and justify why AE and BC were not included as part of the minimum spanning tree. So the answer's down here. There's the values there. Now A to E can be any value 600 or greater, and BC can be 500 or greater. Now it tells you here, AE and BC were not part of the spanning tree because they were either greater than the other edges or they would have created a cycle. So you can see if you joined AE, you could make a cycle with the existing one. Then AE would have created a cycle and BC was not required as each of the vertices would have been connected. Or similarly, if BC created a cycle, AE would not be required. So that's the answer you needed there. Hope that helps you with, we've done this one already. Again, that's one's been done. Good. So hopefully that's assisted you with networks. Thank you.